Hello everyone, welcome to season of AI, and today we are excited to have Sindhura Peri with us, who will be delivering a powerful session on AI and MCP. If you are looking to stay ahead in the world of MCP, this is a session you won't want to miss. So, without any further delay, I would like to invite our speaker, ma'am, to take us on this exciting journey of AI. Ma'am, please continue.
Yeah. Thanks, Sudhanshu. Am I audible? Hello?
Uh, Ma'am, you are
I'm
audible, but the thing is, in my StreamYard, there is a glitch. Hello, ma'am.
okay.
There is a glitch in my
In your StreamYard.
like.
Okay.
I won't be hear you directly. I am listening to you on a different stream. तो थोड़ा
Okay.
सा
No,
delay
no
है
worries.
उसके बीच में.
No worries. No worries. Thank you. Okay. So let me start. So my name is Sindhura and I work for Microsoft as a software consultant. So right now, today we have AI and LLMs across the whole internet, and without bringing into the game, we have to know multiple use cases of what exactly AI can bring into our daily life scope, and how we can use AI with more productivity to increase our productivity and uh, use it in our day-to-day life. So if I can just kickstart it with my session, I hope my screen is visible. Okay, okay. So in today's agenda, we will be starting with what is MCP and how does it work. How do you use it in your day-to-day life with your multiple tool set, and how do you integrate into your workflows, and how do you basically get more productive with the use of it? And next, what is exactly the features of MCP and in-depth overview. And next, we will be deep diving into real-world scenario, the Microsoft Learn MCP server, and last, we will be building a very, very, very small MCP server and running it live. So let me straight go into the next section. So today I will use Python case studies and Python use cases everywhere. So this would be the link if in case you want to take a deep dive into it later on after the session. But as we move forward, okay. Now to be very starting, I will not even kickstart on the MCP, but let's first take a step back and think what exactly is agentic coding all about us. We are hearing many buzzwords in day-to-day life. Yes, we had all the details of LLMs, and we have seen multiple ways that what exactly the agents are being doing for us. Those are nothing but our autonomous AI pair programmer, and which executes, iterates, multi-step tasks from everything from your PC to running your small web server to running the big API and help you debugging in a very very it even goes to multi-level steps and can debug for you and identify things for you. But how exactly we will use this agentic mode with the help of MCP will is much more powerful and a game changer when you want to integrate into your daily workflows or even build any LLM use case in your workflows or in your intelligent applications. So okay. So, what is the big challenge about this? So, we think that we have a React application on the front end. We know there is an issue on the front end, and we could directly ask the LLM, or the here I'm using the GHCP, but we can ask GHCP directly, the GitHub Copilot directly for us. But what are the issues in while we are debugging? So are the dependencies installed? Are the components are fine? Where are we exactly getting the issues, etc. So here, what would be the real challenges for us? First is the context. There won't be any real time context for each and every use case you are debugging, you're connecting to. Or if here we are talking about just a plain dependencies, but what about the database, your GitHub issues, your multi-level steps where you might want your application to talk to multiple tools in the background, in the back end, or even a simple GitHub PR which you want to use. So we don't know where exactly the issues will flow. So now, to provide a better context to the LLM, to the uh, GHCP itself, how do we do this? We need a standard approach which will help us streamline all these missing parts and help us identify the issues more faster while we are debugging, or while we are writing a code from the scratch. It would be a better pair programming for us, or else we are just streamlining some, for some for the leads of the projects, if they are streamlining things in the ADOs or boards or any other use cases. So everything will be streamlined with this. How will be, it's a big gap here, what we see. Now, how do we solve this is the real game changer. Now, let's deep dive into it. The need for MCP arises because of this integration chaos. So we see that there is an agent. Tools are integral to the agent. Now we see a client, be it a VS Code, be it a cursor ID, it could be any ID is what we use today. Those are clients for us where we are working with the code and all. So when we see in the real time use case, we are dealing with multiple tools here. So if we want to fetch some file from the SharePoint, if we want to fetch some container images from Docker and see what exactly is the issue, or if we want to simply boot or connect the file data from the SharePoint to our application for the document intelligence, and we want to provide that as a knowledge base to it. How do we do this? This is a big integration mess what we have here. Now, how do we solve this? Is the need for the standard MVP, which is like a standard protocol for us, which helps in a unified approach. It helps us connecting to all these different tools and give us a unified framework or approach to further uh, integrate all those tools into our uh, development process. Yeah. Now, what is MCP again? Like we are talking about from for a while right now. MCP is an open protocol that standardizes how the applications provide context to the LLMs. So there's a small analogy like how people call it. It's like a USB-C port for your computer, like, but the MCP is the support which we are providing for the AI. So next we will switch on to the next one. Okay. So as we all are saying MCP, but just to give an overview of it, what exactly it means, it's a model context protocol and it is created by Anthropic community, Anthropic team, and which has developed the Claude models for us to use, and it is being used and adopted by the AI community, and it is evolving together day by day. We are seeing a lot of MCP servers hosted by majority of the providers for us today. So, what are these? These are the different hosts we have. Windows, our VS Code, Visual Studio. These are the different hosts what we have, and the clients. Again, client is also the same. We have multiple clients, and then parts coming to the servers. What are these servers? Now we have a GitHub server, we have Azure, we have Foundry, we have our own file search in our own workspace, file stream where we want to, fetch the directory data or get some information and insights about the GitHub repos and understand what exactly is going on in that GitHub repo. For example, you want to review a PR from the GitHub which has published by your uh, colleague, and you're struggling to understand and you want to do it very quick enough. So here our GitHub MCP server will integrate that PR with your uh, code base. You can easily check, okay, where the files were changed, what are the files which has changed for what purpose, and then you can take a very informative call on what you have to extend in your code, looking at these historical changes, which we can with a natural language prompt. We don't have to read all the lines of code what was historically developed. So all those things are very much streamlined for us. Now, let's go to a small demo of seeing MCP in action. I will show MCP server for GitHub, which I have already configured, but just in case if anyone wants to configure, the first step would be you install this. We will see a quick demo on how to fetch details from the GitHub repo using this MCP of GitHub. I'm using a VS Code today, VS Code. So when I click on this GitHub, it is already installed, as you can see. But if you try to install it, it will ask you for a path token. If you provide your path token for your GitHub repo, it will be installed and set up. But we need to even make sure if the MCP is running or not. Once we make sure that MCP is running, then these are nothing but the GitHub uh, MCP once we install it, and then we can see the context. I will go to quickly the tools, and then we'll type GitHub here. Okay, let me type pull request. Okay, I am giving an action called, I am only giving it authorization that get the information on this specific pull request in the GitHub repository. This would be our context. This particular tool will be our context for the GitHub MCP server. And I will, I already did a small check before the session, but yeah, I am asking, okay, get me the details from this particular pull request. This is a public repo. And help me understand, okay, what exactly it is. I'm not asking any question. I just pasted the URL. It will give me all the details what was done in this particular PR. It will fetch for us. So this is the GitHub. If we expand this particular part, so the MCP server what we have set up in the Git VS Code is being involved here. It's fetching this particular MCP server and giving the input to this MCP server saying, okay, this is the method what we have to get, and who is the owner of this repo, and what is the pull request number, and the repo details. So we saw that there are few details for fetched in the output here, but if we collapse this, we can see a readable format of the table, which is the output for us for this particular PR. Now we didn't do anything. We just gave it to a connectivity hub, connection to that GitHub MCP, like a knowledge base, and asked about certain details of this PR. Similarly, you could even give it some certain tasks, but more important thing what we have to do here is we need to do this in the agentic mode. This is the catch here. So when we set that agentic mode and click on the add context, and then once the MCP server is already set up, we uh, set the context saying that we need the request details about the GitHub pull requests and all, then when you set that particular context, then it will fetch us all the details of that particular uh, peer like we have seen. So this is the we will take a deep dive into it what exactly uh, this component is called in MCP. But this is one of the use cases of the MCP. Once we set up the MCP server, I have done a small demo of how do we do fetch these details. So similarly, we can even these are built-in requests. If you see GitHub issues, we can easily give any particular GitHub issue here and try to analyze it uh, in your Copilot chat itself here. So yeah, okay. Now let me again share the slides. Okay. Like we have seen very, very quickly how to set up a small NCP server. Now going into the next slide to understand, okay, what are the details of MCP and what is, let's deep dive a bit into it. Now, now MCP client, how it works. Okay, so it has three different core components, you can call it. One is tools, second is resources, third is the prompts. uh, for the MCP client is nothing but the IDE. If you think the IDE is the client for us today, which invokes the tools which is sent to the MCP server. Like in the demo, what we have just saw is the MCP server of the GitHub, which we have invoked a tool called GitHub repo request read. So this that is a example of a tool. Next, second component is queries for resources, again, all the MCP, all the components in the MCP server are exposed so that the client can use it. So if we are aware of the simple client server architecture in software programming, MCP also follows the similar kind of approach. So there is a client which sends certain queries to the server, and server responds back with the details to the client. So that is the simple approach what we have already for the client server. You can think of that analogy here when we think of MCP client and MCP server. So the third one is the prompts, which interpolates or which provides extra instructions and extra details in aggregation to the tools and resources, and it will get us more fine grained summarized report as the output. So going forward, okay, like I was saying, tools. Tools are model controlled. These are already inbuilt tools for each MCP server. When it is built, it is created. There are certain tools which is exposed by the model itself. So these are nothing but the functions which are invoked by the model. So these are internal or inbuilt functions or methods of the MCP server itself. So here we don't have any control. It is completely model controlled. What is the use of it? It retrieves, searches, sends a message, and in return, if it might even, you can give it simple task. Okay, please do update the DB records of a particular database. Like you can add an MCP server of the Postgres to your IDE, and you can give it as a simple task. Okay, please do update the database records of so and so table. And if you give the authorization to it when you are connecting or installing your MCP server itself, then it will do that task for us. So that is the MCP tools here. Next comes the MCP resources. So like I was saying, this is completely application controlled data which is exposed to the application, like any files, database records, or any API responses of the particular application what we are uh, contacting or setting the context to. That is the resources, but it is also completely application controlled. So we don't have any control here while we are using it. It is a predefined application set what we get, and we use it. Like for the GitHub also has certain resources, we will use those resources so that we will attach these files and make our LLM call much more context aware. And next comes the prompts. Prompts are user controlled. These are predefined templates for our AI interactions. You can give it particular, you can control your prompt in such a way that you can get a, very fine grained response from the LLM, uh, with of course proper context. That is very key. Uh, Prompts, predefined prompts, these are for the AI interactions. Like you have some transcript summary, we will instruct it saying that, okay, please output output whatever the response you are summarizing as JSON format, or please output as in the tabular format. So that is the prompt which you are controlling here, and you're controlling the output of the LLM response using these prompts. Now, yeah, like we are just discussing earlier, here we are having the MCP tools. What are these MCP tools? We have just discussed about this. So the functions, like I was saying, these are the functions which MCP server itself exposes, so that when we use it from a client, that functions the LLM uses, and it performs specific actions use by basically by calling that particular function. So here in this screenshot, we have an example of running a website and taking a screenshot. We can clearly see that there is an NPM tool, the NPM tool Node Package Manager, what we generally use for all our TypeScript and other uh, installations. So Node Package Manager we have, and next it starts. We are clearly saying it started a development server here, which is nothing but an MCP of the npm here. So and then we see that it navigated to a URL. We have a Playwright MCP server again. There are two MCP servers which is running this. Playwright is a SDK for testing, and we know that Playwright also exposes its own MCP server. So, and that means it is running a website using this npm development server and taking a screenshot using the Playwright MCP server. So it is only taking, we have just given it the uh, the the NLP command, and it has done this. But the prerequisite to have to this to happen is, we need, when an MCP server is set up, it it must be started in the VS Code or Visual Studio, wherever you're using those extensions. It must be started, and that tool should be enabled for the use in the GitHub Copilot. Then only it can, when you are asking a plain request with the help of in the natural language as a query, it will only take a call of to contact which particular MCP server and do the certain actions what we have instructed it to do. Yeah. Now going to the user controls, as I was saying, yes, the same thing. Per chat, tool collection, selection, all these, maybe we will take a very small deep dive into it. The tools part we have already seen. We need to go to the tools part here. The agentic mode is set here, and uh, when we click on the context, we can add context here. We will see a search bar, and inside that search bar we will see these tools, and with which we can provide that particular context and provide select that particular tool with which we want to certain or achieve a particular task. Next is the resources. Okay, so resources are nothing but an date. We are exposing the data in a read-only fashion as URIs. If we can see in this particular snippet, we can see we are providing the resource as a context to the chat. What is the context we are setting here? It is a repository content. We are saying it is. when we select this particular MCP resource inside the VDE, also inside the IDE, then it will ask us what particular MCP resource we can set up. But this is coming from the GitHub MCP server. That is a prerequisite. When once that is set, then we can provide all these resource templates and details, specific branches, specific schemas from the repo, specific images, all those details we can fetch it from the remote uh, repository into the chat as MCP resource. So this is the data what we are providing to the particular chat or the session of the chat, so that our responses would be context aware, and it will not hallucinate much and give us the details based on the context we have provided. So this is nothing but the use cases of real time context and what we are providing everywhere. So yes, use how the use cases for the resources would be: make data accessible to clients and users, like we're saying. So here we are saying that, okay, reduce the response tokens, returning, we are saying we are reducing the response tokens, and we are giving only certain, uh, we are exposing certain list of files as a data to the context, not the entire assets folder for the use for the MCP to take the action. We are reducing the token size so that we can reduce the embeddings, and then we can reduce the even tokens to the set as a context, as well as if the input tokens is controlled, and then output tokens can also be controlled by setting with the prompt saying that, okay, I need only specific details, not a hallucinated content, and I need the output in the specific format, okay, which would clearly reduce the response tokens, and also will give us more uh, fine grained response again. Yeah. Now coming to the prompts. Prompts are the game changers for any LLM activity, even for simple GHCP queries. What we do in a daily in a daily day, uh, in every day, or even we are building a agentic AI workflow. Then also prompts are very key. Apart from all the other key things, prompts are also playing a very good key thing. We will see certain times using predefined templates for AI tasks, explicitly invoked by the user. The response which is generated by the LLM will drastically change, and sometimes it would be much more accurate when we provide much more context, and much proper predefined prompts as a template. We ask the LLM to fill the placeholders with the required output. So we will say that, okay, please, here we can see in this particular one, we are giving the MCP in the response, and we are saying carefully and thoroughly optimize the current code, and then we are giving certain instructions, the instructions in which we can provide the proper prompting techniques, which will increase the accuracy and stop the hallucination also to certain extent. So we have seen from static templates to dynamic generating workflows, we can do many things here by changing the prompts. So yeah, now here it is. N- We will deep dive how an MCP architecture works on a high level. So this is the host, all the IDs, VS Code, Visual Studio, Cursor, all the IDs you have. This is the host, and then you have the client, which is a chat window of the GitHub Copilot itself. You could use any LLM, but any model behind it. But here the client, or any client, Claude Desktop, any client we can use. But this is the client for us. GitHub Copilot is the client. And then we have an MCP protocol, uh, which standardizes the approach of handshake between the client and the server. And then using this MCP protocol, when a request is sent to the MCP server, it again based on what MCP server it is. If it is a file-based MCP server, it will go to the local its own data source from where it is exposed. The server is exposed. It fetches the information back, and via MCP server, again we use a MCP protocol for the translation, I mean for the response back, and it gives the response back to the client for us. So like I was saying, same thing. So now again, this is one of the use cases. For the other use case, what we have same MCP protocol, and there is one more MCP server, and using the GitHub APIs, what we can see is we are connecting to the local database, local internet database, and fetching from that from the database the information, and go back to the server and then the client. So this is nothing, like I was saying earlier, this is nothing but the basic, very basic client server architecture of the software engineering, or yeah, we call it is the age old client server interaction what we are having here. Yeah. So and then we have a MCP protocol in a remote server, which is established to the remote server, and it is connecting to a remote service. So this is how the entire picture is, uh, how from the host, from the client to the server, the request is traversing, and how we are getting back the details. Okay. Now we go to the real world scenario. Now we will delve into the details of the Microsoft Learn MCP server. What exactly is the Microsoft Learn MCP server, and how can we use it effectively in our whenever we require. So Microsoft Learn Server is the MCP server which is hosted by Microsoft for the Microsoft Learn documentation itself. So they have exposed this MCP server. So it's a remote server basically that enables the GitHub Copilot and other AI agents to uh, bring the trusted and up-to-date information directly from Microsoft Learn. As we know, each LLM, each model has some cutoff date, and after that, after the cutoff date, if there are any updates for any specific product in the Microsoft Learn, those information will not be real time transported back to the LLM whenever the user or whoever requests any question to the LLM on that after that particular cutoff date. So then those kind of scenarios we will use these MCP servers along with the to the GitHub client GHCPs to get us the real time data and give us back the actual information, and we will ask in a very natural language no questions as a prompt basically. So how this MCP will give AI agents the right information is, we have certain functions which the server exposes as tools. We saw like Microsoft Doc search for focused concepts, and this server can search basically Microsoft content, and it will return up to 10 chunks, and then it will even give us the citations inside it. And then we have another tool called Microsoft Docs Fetch for full technical implementation and and documentation from the Microsoft Learn page. And then we have a sample search tool which will give us the code snippets, and it surfaces the accurate code information for our scenarios like deployment scripting or configuration when you want to understand, and when you are just implementing a POC or a new uh, anything like maybe a Azure service bus, you can take the point. Okay, when we use this particular tool Microsoft Code Sample Search for a specific implementation for the service bus, then it will give us the code samples in that particular page itself. We don't have to go and search for the web for that particular page, and traverse through multiple links. So this would be very helpful for us. How do you use it? We have set up the GitHub MCP server. We will set up a Microsoft. Microsoft Learn MCP Server 2. So that the Learn MCP server will be accessible by the Copilot, and we can use much more details, and we can see ask questions like this. After the slides, I will show how to use it and how to quickly ask the questions to it. Okay. So what so the developer is asking here, how do I deploy containerized app to Azure using Bicep and GitHub Actions, validate the deployment pattern and provide IAC examples. So then it started the MCP server, and it is fetching from the Microsoft Docs search, and twice it has fetched twice from it, and then it is also creating the Bicep infrastructure. We can see from the learn page, and then it is also describing what it has done, a basic documentation, what after the implementation, what a developer would do. So done. And there is a pro tip here. After you have done this exercise, you could ask the MCP server of describe how you have used the Learn MCP server, and what all details you have fetched, and how did you even design the low level settings for it, and created the entire modules, like which AVM modules you have used and all that stuff. We can ask it. Okay. So it will return all the details, like. So now, going to the official SDKs for the MCP. So we have C sharp, Java, uh, Python, in all the TypeScript, in all the languages we have the MCP launched. Sorry, MCP SDKs. We can search for it in the marketplace, in the uh, online, and see the documentation, and we can kickstart it. It is like any other framework what we use. Now we will go and quickly switch our. No? Okay. Now I have taken this from the repo which I have shared earlier, shown earlier in the start of the page, in the first demo. So this is the MCP repo, MCP learn repo, and we have taken the example of Python today. So there are bunch of examples in this particular repo which you can start checking and learning. Uh, so mm, we will first look at this mcp.json here. What we have, this is in for any MCP server, we need to provide an input JSON, which is like bridging the gap of how this particular command is running, how the MCP is setting up for us. And also it has, for any programming language, we pass certain arguments. So this is also taking certain arguments based on what has written in the code. So I will not dive very deep into it, but we will go and see a small MCP server, which is a Python learning buddy. Uh, the instructions are very clear here, how to set it up and all, but in the markdown file. So let me go and, yeah, this is the actual Python file of this particular server. How do we uh, uh, how to, you know expose this particular MCP server and use this further. So now we will see how to build this and then use it also. So like I'm showing, this is a small study buddy kind of thing, MCP server, which will help you surface from the Python documentation all the details, and you can learn Python quickly using this MCP server. So you can see all the details are there. We are passing a little few exercises to it, and we see this is the script which will make us sure to run this. And we will go to one more file where we can see the prompts. Yeah, prompt server. Okay. So this is the MCP dot prompt. What will make us make this as a MCP server, and whenever we with this particular decorator here, what we see MCP dot prompt, when we expose this and run this MCP server, we can see when when it is exposed and running, we can see these prompts between what we have already set here, and it would run based on these prompts. We will run and see the working of it. Okay, you can pass your user here, username, whichever username you want to. Now I am passing a beginner, so it will pick from the beginner session and give us a small gaming kind of interactive console where you can learn as well as you know this is a very 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 basic MCP server. You could expand this into using a web application. You can basically as a front end you can develop an interactive gaming session, and as a back end you expose an MCP server and which is connected to an LLM obviously. Then it would be a small gaming session what you are building here using this. So now I go. There are different difficulties and stars not started. We could even try to fetch all the algorithms, DSA. You can learn anything here. So here you are benefiting from two things. You are learning the software engineering concepts as well as MCP uh, with this approach. So what is it asking? So I'm not writing this entire code, but what it is asking. So I've ran that MCP server, and I asked, okay, I'll go with the first approach. Then no, first one. Oh no, okay, I selected the third one, the multiplication table, and so what it is asking me to do? It's asking me to write a program that prints multiplication table for a given number. Okay. Now I'm saying I don't know. I don't need any hint for in test. No, I'm not writing the code. I'm asking it to give me the solution. So we can see it has given me the solution as well. The solution snippet. Now it's asking me, did you really complete this exercise? I'm saying no, I didn't. It's asking me to continue to another exercise. I'm again saying yes. So it is again giving me the table which we have, and it's asking me to select from it. So here we could see very clearly. Okay, behind it is contacting the LLM, and it is doing all this stuff for us. Okay. Now again, I'm not doing into anything, and I stop it. Now let me run it again, and I have ran the intermediate one. Now again we are it's saying okay, this is the difficulty of it. It has said okay, I'm this is the list comprehension what you have to do. So we are choosing the exercise, and it is asking me to create a list of squares. So like this, it is now this is a very simple MCP server what we have built. We could host this in the list of MCP servers what we have already together and today, and as an open source, and we could use this. This is one thing. And second one, you could even connect proper knowledge bases for it, like multiple different MCPs, and you could create a multi-agent workflow which has the interaction with the MCPs so that you make it a very streamlined AI workflow. So like this, we can do we can build multiple use cases using MCP. So that is a very quick demo what I had. So okay, let me again start the show. Okay, so I wanted to conclude before the Q&A with this small slider. Today at Microsoft, we have multiple clients, MCP clients and hosts. Like we have seen, there is a Copilot Studio, VS Code, Foundry Agent. All these are the multiple clients we have, and then we have multiple tools of which has support for different structures. Like we have Azure tools which we could use, the built-in tools, the GitHub built-in tools, and then we could use Atlassian ones for the Bitbucket and conference details. You could use all these tools integrated into your clients which you use, and then we have multiple registries which is here, and we can see we have we can build it with local MCP SDK. This is the C sharp is the SDK, but you can use Python, JavaScript, any Java. All these SDKs are supported right now. So you could use MCP with the MCP SDK. You can build with the Azure API management and use multiple Microsoft connectors and make it a big, full-fledged and LLM app. Which has multiple knowledge bases and which enables the seamless integration between the LLM applications and the external data sources. uh, like we have seen, this is the big this is like building the bridging the gap between the client and the server, and building giving us a standardized approach to use it. So that's it from my side as a wind up. In today's tutorial, what we have taken it's from the examples. This is the C sharp one, but I took the example of the Python. You can find you can just replace the C sharp with Python and Java, JavaScript. You would find for all the languages. You can find more training and more details in these particular uh, 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 links. And at last but not the least, we have a AI community, AI Discord, where we post use cases, real life use cases, multiple complex use cases, advanced use cases, where MCP is really supported and used for in our day to day activities to bridge gaps between multiple and solving issues. Yeah, that's it from my side. If you have any questions, if anyone is having any questions, please go ahead. Or uh, hello.